Hello everyone, welcome back to my channel. My name is Piyush and this is the fourth video in the series 10 weeks of CloudOps. In this video as well, we will be building the project end to end from the scratch. So you can follow along with me or you can pause the video wherever you feel you need more time and you can then continue as per your convenience. And in this project, we'll be doing a lot of things. It's gonna be a big project. So we'll be Dockerizing an application first, and then we'll be provisioning an EKS Kubernetes cluster using Terraform custom modules. We will also implement CI using CircleCI and GitOps using ArgoCD. I will also try to explain each and every concept as we go along in this video, and we'll be setting up the tools and all the infrastructure from the scratch. Without any further ado, let's get into it. Alright, so this is the diagram that we will be following. By the way, this diagram was created by my wife Himani Chauhan. She implemented the end-to-end project and created 4 blocks out of it. So if you want to refer those blogs as well, I will put the link in the description section and you can refer those. So it starts from here when developer perform the code commit through a pull request or the direct merge into the requested branch in GitHub repository. The code is then pulled by a pipeline, which is CircleCI is the CI tool that we are using over here. So CircleCI detects the changes in the GitHub repository and then it triggers the pipeline. So this is the trigger. So the code commit, pull request, or the merge, this is the trigger. So as soon as the trigger gets received by the CircleCI tool, this pipeline is triggered. So this pipeline will test the code, build the code. We are not doing testing in this project particularly, but we'll be doing the rest of the steps. So along with the code in the same repository, there is a Docker file. This Docker file will also, sorry about my handwriting. So this Docker file will be, building the Docker image that we will be using as part of our deployment services. The Docker build step will be taken care by CircleCI automatically. Then the image will be pushed to a container registry such as Docker Hub. Right? There could be other image repositories such as Artifactory, ACR, GCR, and there are many more. I'm using Docker Hub in this particular project, so that's what we're going to use. So you can push the image with that. Along with the image, there'll be a tag associated with it. I'll be using the build number as the image tag so that we can uniquely identify a particular image, right? So once it is pushed, it also updates the manifest file so that ArgoCD also knows that there has been some changes in the existing deployment file, right? So it updates the manifest file and then send the changes to the ArgoCD. ArgoCD detects the changes and then it will push all the changes to the Kubernetes cluster. So we have a control plane component over here, which is deployed in 3 availability zones for high availability and fault tolerance. And then we have worker nodes deployed in 2 availability zones, right? Backed with the NAT gateways, load balancers and everything. So this ArgoCD will then update these pods that are running as part of our application, and these pods are exposed by a service. So this is what we are going to do. Over here we'll be interacting with our Kubernetes cluster using the kubectl command line utilities. I will show you everything. Please don't get overwhelmed just yet. I will be explaining everything as we go along in the video, so concepts will be more clear when you see it in action. So let's start with our first step now. Okay, so as part of first step, I will go to my AWS console and I'll create an IAM user to create and manage resources from Terraform. So I'll just go to the IAM service and then click on users over here. Then create a user. Give it a name. Let's call it Terraform user demo 4. And we don't want it to be accessible through management console. Just the CLI access is what we need. So I'll uncheck this box. I'll keep it the way it is, the default way, and hit on next. Then I could add this to a group if I had an admin user group, or I could have copied the permissions from some other users. But let me just directly attach the policies. So what I need is, like, I would need a lot of permissions to, provision the cluster, manage the cluster, and then a lot of other things. So it's better I'll just provide the admin level permissions. But this is not the secured way of doing things. So make sure you are aware about the consequences of using the admin access to any particular user. So I'll then click on next and I'll verify everything. Everything's good. Hit on create user. Okay, my user is being created. Let's see. Okay, here it is, Terraform user 4. And what I need to do is I need to create the access keys as well, right? So I could click over here, create access keys, or just go to the security credentials and then create access keys from here as well. Okay, use case is CLI, that's where I need. And then go down, I understand the recommendation, then hit next. Description, if you want to give it a description or just keep it blank. So I'll just give something like demo 4 Terraform user, create access keys. And then, you can copy and paste the access keys somewhere safe, because once you click on done, this won't be visible, or you can just download the CSV file for your future use. I'll just store it somewhere safe in a notepad file for now. I'll copy this one as well. All right, I have copied it. Now I'll hit on done. Says that you haven't viewed or downloaded your secret key. It's okay because I have copied it. So I know what I'm doing. So that's okay. Continue. And it is active now. Our Terraform user has been created. So I'm in my terminal window and I'll enter AWS configure. Okay, it's asking me access keys. So let me copy it. I've pasted it over here, hit enter, then secret access key, hit enter. Default region is US East 1. Let's keep it default. Hit enter. So now I am authenticated with the AWS account using the Terraform user. Let me clear the screen first, and then I'll clone the Terraform repository, which was created by Himani. So this is the command that I'm going to use, git clone and the name of repository. And again, these all links will be there in the description section. So don't worry about it. Hit enter. I should have checked where I'm cloning to, but that's okay for now. Okay, so it's there in the cube Terraform folder, right? So here's my code. Now let me open the folder as well over here. Okay, hit select folder. So this is the code repository that I have cloned. It has two folders, one with modules, another one is to do app. So here is, this is the starting point. This is our root module. So everything starts from here, main.tf. It will create a VPC using the VPC module. VPC module is there in the module folder itself. So there is this folder for VPC module. So if you want to know like the details about how to create custom modules and how do we access it, so you can refer to video number 3, which is the previous video of this series, and it will have all the details. For now, I'm just going through what we are using, right? So we were over here and it will first create a VPC, then a NAT gateway in both the availability zones, then a module for IAM, a module for EKS, and its node groups for hosting the worker nodes. And all the details of all the modules are present over here in the module folder. It has some other files. The first one is backend.tf. Again, this is also I have explained, but let me give a brief refresher about the backend. So when we use Terraform, we create something called as tf state file. So this tf state file has the current state of the infrastructure that is managed and created by Terraform. So this file is really important. This file has to be secured somewhere remotely and not in the local system over here. So that's why we are using a remote backend. That means this file will be stored in a remote S3 bucket with this name and in this particular folder. and it is backed by a DynamoDB table. We are using DynamoDB table so that it can support the remote locking of the file. So this file is doing that, and make sure you have the bucket created already and the DynamoDB table. Let's verify if we have, else we'll create one. So I'll go back, go to S3 bucket. First we'll check the bucket. Okay, so let's see where it is. Bucket name should be EKS Terra bucket, or I'll just create a new one. That's okay too. So 10 weeks of CloudOps and hyphen week 4. So this is the name of the bucket that I want. Go back, create bucket. Bucket name should be available, and US East 1. Let's keep the default location. And by default, it will be a private bucket. So that's what we need. And you need to keep the bucket versioning enabled, because this file is really critical. And if someone accidentally deletes the state file, there is no way to recover it. So make sure you enable the bucket versioning so that you can roll back the previous version if it was deleted or modified accidentally. Right, let's keep everything as default and hit create bucket. So now our bucket is created. Now quickly check the DynamoDB table. Go to DynamoDB, go to tables. Oh, we do have the table. Let's create a new one again. We'll give it the name 10 weeks of CloudOps Dynamo. Copy this name and hit create table. We'll give this the name. Make sure you enter the partition key. This step is really important. So give it a name, lock ID. It has to be like this in the exact same format. It has to be type string. And rest all, keep the settings as default and hit create table. So our Terraform prerequisite is done. It should be created shortly. It shouldn't take much time. Okay, it's been created. Now let's go back. So this was our main. This is backend.tf, and then we have a provider. I'm using one of the latest HashiCorp AWS provider in the same region that we are provisioning our resources. In this file, these values will be passed as the variables to the Terraform configuration. So you can update these values as per your requirement. I'm just keeping it default, to-do app, US East 1. And this is my VPC CIDR. And these are my 4 subnets. So these 2 subnets are for the publics. These 2 are the public subnets, and these 2 are the private subnets. And we'll see how we are using it in the project itself. And these are the variables that I have used throughout the project. I guess we are done with the prerequisites. Now let's go and provision the infrastructure. So I'll just open a new shell. Okay, so I have started a new shell, and I'll just create an alias. And it will save us some keystrokes. So alias tf equal to Terraform, so that we don't have to type Terraform every time we are running the Terraform command. We clear the screen and run Terraform init. But first, let me check in which directory I'm currently at. So I should be inside to-do app, our root module. Now let's run tf init to initialize the modules. So it will initialize the backend. It will backend as S3. If you could see over here, it says successfully configured the S3 backend. And then it will initialize the modules that we have created, and it will download all the dependencies and provider plugins. In this case, this is HashiCorp AWS version 4.67.0. So this is what it will download. So it's done. I don't see any error. It says it has been successfully initialized. Let me clear the screen and run Terraform plan to see what changes will be done once we run the apply. It has some warning which says argument is deprecated. So we can ignore this warning, because this argument will be replaced by something else in the future releases of this provider. So, but we can ignore this for now. And it says, let's see, 26 to add, 0 to change, 0 to destroy. That means 26 resources will be created once we run Terraform apply. You can add a grep command with this. So let's say will be created, and it will show you like all the resources that will be created. Okay, so let's see. Okay, so there is the EKS cluster, then cluster role. Cluster role was part of the IAM module. Then we have node group, policy attachment, ELB, worker nodes, NAT gateways, route tables, subnets. All the resources will be created once we hit Terraform apply. So let's do that now. Terraform apply hyphen auto approve, because we have already verified. Hit enter. So now it will take, I'm guessing, around 10 to 15 minutes before our services are ready. So I'll just pause the video till then, and we'll come back shortly. Okay, so after a few minutes, I see the apply has been completed and 26 resources has been created. Now let's have a look and see if it actually created. So I'll go to my EKS cluster first. Okay, this is the cluster that was just been created with this name. This name came from the terraform.tfvar files in which we have specified, and it was just created 12 minutes ago. Let's click on resources. It doesn't have any deployments created yet. But if we go to the clusters and we see nodes, probably my user doesn't have access to view nodes from the console at the moment, but we'll have a look from the backend. So that's okay too. But just wanted to see if a cluster has been created, and it surely does. And other than that, there should be a VPC. Let's see the VPC as well. Okay, VPC. And this is the to-do app VPC that was created for us. And if you go down, it has 4 subnets, 2 public, 2 private. It has 4 route tables, and it has 2 NAT gateways, 1 internet gateway. Everything was created by our Terraform configuration that we just ran. So we have verified everything. It looks good. Now let's go ahead and log into the cluster. For that, we will need a kubeconfig file. So let me go to my VS Code, clear the screen, and let me see if the region was set for this terminal window. No, it was not. So let's export a couple of variables. Region is equal to US East 1. And then one more variable, which is the cluster name. Cluster name, it was to do app. Okay. Now let's run this command to generate our kubeconfig. The screen, and this is the command AWS EKS update kubeconfig. Region is what we have set, and cluster name. Hit enter. Okay, it says added a new context to this particular location. So this is our default kubeconfig. Now let's do a kubectl get pods. Okay, it says no resources in the default namespace. Let's see in the kube system, because it should be there in the kube system namespace. Okay, it says all our control plane pods are up and running, which is nodes, core DNS, kubeproxy. Let's quickly see our nodes as well. kubectl get nodes. So yes, 2 nodes have been created, and they both are in the ready condition. These 2 are the worker nodes. Because we are using a managed Kubernetes service, we won't be able to access the control plane nodes. So these 2 are the worker nodes. So yes, we have verified our configuration. Our EKS cluster is up and running. Now let's move on to the next part, which is setting up CircleCI and ArgoCD. Okay, so first we'll go and create an account on CircleCI. CircleCI login. We'll be using the web version of it. Yeah, I haven't created it yet, so I'm just following along as I'm going through the demo. So let's authorize to the GitHub. Okay, it says set up your code. So I'll use my personal organization and set up the repository. I might have to create a new repository for it. Let's see if it's giving me the option. Okay, I cannot choose it from here. So let me go to my GitHub and create a new repository. Repository name, let's give it app code. So we'll be creating 3 separate repository, one for app code, one for Kubernetes manifest, and one for Terraform configuration. So this is for the app code itself. I'll add the README later on. Create repository. Now in this repository, okay, I'll create a folder called a new file. So I'll create a file inside the folder .circleci, and inside that the file name would be config.yaml. Okay, content of this file, I'll just paste it here from Himani's repo, and then we can make the changes as we go along. So if you see, so this is a CI pipeline as we discussed. So it starts with jobs, and we have jobs such as build and push. That's job number 1. The second job is update manifest, as what we have seen in the diagram itself. So let's start with the first one, which is build and push. It is using a node image with this particular version. It is doing git checkout, and it is running on a remote Docker machine to build the image. Then we have a CircleCI build number. This is an environment variable that it will populate, and it will append this at the end of the image. Here we are just doing an echo on the version, this like if it's been set properly or not. And then we'll be building our source code where our actual to-do application is present. Right? So I'll just change the repository. Okay, so I have made the changes over here. Now it will be doing the Docker login using the Docker username and password. So we'll be setting these credentials in the Docker Hub environment variables. We'll show you how we can do that, and then we'll do the push on Docker Hub. Okay. And the next part is the update manifest part. And again, we are using a public image. And similarly, we are doing a remote Docker build. Tag is the environment variable for circle build number. Circle build number is over here, the same that we have used in the version. And then it will be doing a git clone from the repository where the kube manifest is present. So I will change it to my repository. I will be creating all the other repositories as well. I'll be using my email and then username. Yes, it's Piyush. And then it will update the build number in the deployment YAML file. Okay, so I'll just keep it as it is. Then it will make the changes. It will do a git add, and then it will push the changes using the GitHub personal token. Again, this will be there generated from the GitHub. I'll show you how we can do that as well. And it should be okay. And then here's the workflow from where it will start the execution. It will first run this job, build and push, then it will run update manifest job, and it requires build and push. That means we are setting up the dependency. Let me zoom it a bit. So over here, it is setting up the dependency that this particular job requires build and push to be completed first. So that's what it is. Okay, let me commit the changes. Okay, so I have created one repository to host our config.yaml of CircleCI. Okay. Then we'll go to GitHub and generate the access token. So I'll open a new tab, go to settings, and then developer settings at the bottom. And over here, personal access tokens. Okay, you can create a fine grained token. Click on generate new token. Give it a name. Call it 10 weeks of CloudOps demo 4. Okay. Give it the public repository access. Okay, let me give access to all my repositories. Repository permissions should be okay. Let's keep it default, and we'll fix it if it throws any error. And then generate the token. Copy it from here and save it locally somewhere safe. Okay, now I'll set up the other two repositories as well. So our first repository is here, app code. Let's go to GitHub, and I will create a new repository for Terraform as well. So repository name is 10 weeks of CloudOps demo 4 pf code. Okay, initialize a readme and create the repository. Now the code that I have made the changes to in my VS Code, I'll push that to this repository. And let's do a save all just to be sure. Okay, so I'm gonna initialize this repository, and then I'll go and create a new repository here. Give it a name. Let's call it 10 weeks of CloudOps. Week 4 Terraform. Copy the name. Okay, so this is a public repository. That's good. Create. Okay, now let's go back. Already done git init. Let's do a git add commit -m first upload. Okay, it's referring to a different branch. That's okay. Let's set the git remote. Move origin. Then I'll add a new origin, git remote, add origin, and the one that I've just copied. I need the complete name. Let's go back and take the name from here. Now git branch -m main push region main, and it says the files have been pushed. Now let's go back and hit refresh over here. So our files have been uploaded along with the readme. This was from the original blog, from the original GitHub repo that I've downloaded from, so which was Himani's repo. So that's, these names are still the same. I will update it later on, but rest of the details are updated. And let's quickly verify if our changes are there. So we made the changes in backend. Let's go to this, and yes, this is our change. This is the bucket that I created and the DynamoDB table name. So that's good. So now we have two repositories created, one for our application code, which is app code, and then one for our Terraform code. Now we need one more for our Kubernetes manifest. Maybe I'll just simply fork the repository. Okay, so this is the repository that I need. It has two manifests. One is a deployment YAML, right? It will have a deployment with two replicas, and it has one container. This is the image that we'll be building. And there is the service YAML, which exposes this on the load balancer service. So let's try to fork this repo. Okay, I'll hit fork, and I'll give the same repository name as kube manifest. Let's keep it the way it is. Copy the main branch only and create the fork. Okay, so here are our changes. Let's just quickly make the change in the deployment YAML. Over here, my image name was Piyush. Commit the changes. And that's it. I don't think we need any changes in service YAML. Yeah, that's good. Okay, so we have our three repositories ready: kube manifest, app code, and this one. Now let's quickly go and configure the pipeline in CircleCI. Right, so here we are. There was our login. Now we'll set up the project. Now I'll hit the refresh one more time so that our new repositories will be present. So we'll select the organization. We'll select the repositories. So we need our app code, because this is the one repository in which we'll be building the code from. So hit set up the project. Okay, so there it is. It says unsupported or missing workflow config version. So let's click over here. I'm in the project section over here, and then click on configuration file. And here is the configuration file it pulled. Unsupported or missing workflow config version. I guess we are missing a version parameter over here. So let's try to add version 2.1. I guess this is one of the latest versions. So that's okay. Okay, let's go and change it from the GitHub repo itself. So I'll keep it the way it is at the moment. Still there. Okay, so let's go to our GitHub repository, CircleCI config, add it, and make the change version 2.1. Commit changes, updated version, right? Let's go back, CircleCI, and maybe I'll just hit refresh. Changes as good. Oh, it did trigger the build, and it says failed. Okay, it's spin up the. Okay, so issue is something different. So it is spinning up the environment, spinning up the container, preparing environment variable, and then unable to prepare context in the Docker file, no such file or directory. We still need to make some changes. So that's okay. Now that we know at least our config is valid. So yeah, so that's because we have not set the environment variables yet that we have used in the Docker file. Now let's go to hub.docker.com. I'll just quickly log into that, sign in. Okay, so this is my username. I guess this is what I have used. That's okay. Now I should have a repository created over here. I'm using this for after a very long time. So let's see if I'm doing it right. So let's give it a repository. I guess to do app was the name. Let's go back to our app code. And okay, so this is um, my username, and then this should be the name of repository and public repository. That's cool. Create. Okay, so a Docker repository has been created. Now let's go to CircleCI and go to project settings. Here we are, project settings, and now we'll set the environment variables. Go to environment variables. We need 3 environment variables. First is Docker username. So this is my username. Okay. And then I'll add the Docker password, and I'm gonna hide this so you won't be able to see it. Okay, now I'll add one more variable, which is GitHub personal token. This is the one that we have created. So let's add this as well. Now our variables are created. Now let's rerun the pipeline and see if a new image is getting created or not. So let's go back. App code and this rerun workflow from start. Let's click over here. Okay. I guess this one. See the error. It says Docker file not found. Okay. So I just copied the config YAML and I forgot to add rest of those files. So that's why it is throwing the error that Docker file not found. So let me just copy it. It should have the source code as well, the application source code. Here the screen R and app code. Okay, do a git clone on this repository. It will have all the files. Now inside this, I'll just remove .config dot CircleCI rm-rf dot CircleCI folder. Okay, now I need all these files, and let's do a git init and then git remote add origin, and our origin is this one. Okay, it says origin already exists, so git remote remove origin, the earlier one, and add this one. Now do git add git status git branch hyphen m main. I guess yeah, we are already on main, so that's okay. Now git push origin main. Okay, so I have pushed the file using git push hyphen force. Let's go back and see if our files are there. So I see all our files are here, and this shouldn't have been changed. Config.yaml. Oh, it was changed because I have forcefully pushed it. So that's why you should not be forcefully push the code. So yeah, that's okay. I'll make the changes again. I'll just have to make the changes in this file and we should be good. Oh, and over here web and GitHub. Okay, and my email. Yeah, I guess version 2.1 was already there as part of this file. While copying it, I did not copy this part, so that's why we were facing that issue. So let's make the changes now and see if it triggered the pipeline. Okay, so this is what it says running. Let's quickly see. It should work now. Okay, now it's able to pull the Docker image and it downloaded it. It's building the image. There are some warning messages from npm. It's okay. While it is doing that, let's have a look at the Docker file. So this is a Docker file. What it is doing, it is using a Alpine image, which is a lightweight Linux OS image, and it is creating a work directory, copying all the JSON files in the work directory, running npm install, and then npm build, and then using a nginx image, and then also copying some more files to the nginx html directory. So this is pretty straightforward Docker file that we have used. And let's go back to our CircleCI, and it looks all green, which is good news. Green is good. So it says let's build and push the image, and it log in successfully and push to the repository. Let's quickly see our Docker repository, which is over here. I'll hit refresh. And our images have been uploaded over here with the name build4 because there were 3 failed builds. So after that, it incremented the tag version number, and now the build is 4. Okay, so here is our image with all the details. And image size is 67 MB, which is good enough for us. So our CI part is completed now. Let's go to the next and final part, which is the CD part using ArgoCD. Okay, so I'll go to my Visual Studio Code, clear the screen. Okay, now we'll apply the manifest to install all the ArgoCD related objects. Let's hit enter. Okay, so it has deployed a lot of things, including services, ArgoCD, network policies. Now let's quickly see if we see our objects. So get pods -n equal to ArgoCD, and they are still getting created. It will take a few more seconds. Okay, so only ArgoCD server is pending and Dex server. Okay, now it's up and running. Everything is up and running. Now we can do a next step, which is forwarding port so that our ArgoCD application is accessible over the UI. So let me clear the screen so that the command is visible. I'll run this port forward command for ArgoCD server. Okay, so let's see if it is accessible on localhost 8080. Yes, proceed. And yes, our ArgoCD is up and running. So the username is admin. You can get the password. So password is part of a secret that's been created. Let's quickly see over here. So kubectl get secrets -n equal to ArgoCD. Right. So this ArgoCD secret or the initial admin secret is what we need. Right. So you can decode it because this is not encrypted. This is just encoded, which is base 64 encode, and you can easily decrypt it using this command kubectl kubectl get secret and then -name equal to this. So this is the secret name, and this is the secret it is showing. And if you do -o YAML, it will show you the content of it, and then you can easily decode the content. So this is the password, which is base 64, and to decode it you can do echo, paste it, and base 64 -decode. That's it. And your password is over here. Right. So let's go back to our terminal, enter the password, sign in. So okay, we have closed that. So let's run that port forwarding command again so that it should start listening again. And admin, and let's enter the password what we have copied, sign in. We are in our ArgoCD console. Okay, now we need to create a manifest file to sync the ArgoCD with our GitHub repository. So I'll go back. Okay, I have to close it one more time. Just create a new file, or just vi argo manifest.yaml. Okay, I'll paste the content that I have copied. Its formatting is not correct, so I'll use the other way. Do a echo eof. No, it should be cat eof argo test 1.yaml. I'll create a new file. I'll paste the content over here and uf. Let's see now. Cat test 1.yaml. Okay, now it is showing the content. Now let me just update the file. All right, so there's the blank line. I'll remove it. Now name of The manifest is this is good. ArgoCD is the namespace. And I'll just change the repo URL. Okay. Rest everything is good. So what it will do is it will sync your GitHub repository with the server itself, with the EKS server. Okay, and destination is this kubernetes.default.svc. Namespace is my app, and path is manifest. Inside manifest, there'll be two manifest. One is deployment YAML, and the other one is service YAML of this GitHub repository. And then sync policy is create namespace equal to true. That means if the namespace does not exist, it will create it, and it will self heal itself if there is any failure. I'll just save this and apply this manifest by kubectl apply -f and argo manifest 1.yaml. Okay, so it says it's created. Let's quickly see kubectl get pods, and its namespace was my app. Is image pullback off. That means something is not right with the image name. So let me run that pod forwarding again. I should have used multiple terminals instead of doing this all over again, but okay. So now it says status is progressing and repo is synced. Let's see, it should be healthy. Sync is okay. And these deployments are in progress. And over here, you see it says container is waiting because image pull back off. That means this is not correct, right? So now we need to see where it is failing, why it is showing that image is not present. So it should pull to do app build 25, right? And if we go to our Docker Hub, let's see which is our latest image. We only have build 4. Why it is picking up build 24? Okay, this is our deployment YAML. Okay, because it's been hard coded over here 25, because remember I have copied it. Like I took this deployment YAML from the previous repository, so first time it will fail. Now let's do one thing. Let's rerun it again so that as part of the process, it will update that build number. So where it is doing that change, let me show you that before. Let me show you that first. So in our CircleCI YAML, config YAML, you see it is making that change through a set command over here. It is updating that build number inside the deployment YAML. But for the first time, it will use the same one. So let's go back. It has to run the CI again to update the build number, right? So, okay, so this one wouldn't make any change. Let's make some change in the application code itself so that it will trigger the CI again. So I am in my application code. Okay, let's go to app.js and edit this file. Inside that, let's see, 10 weeks of CloudOps to-do list. Commit the changes so that it will trigger a new CI build. If we go back to our dashboard on CircleCI, it should trigger a new build which is running, and then post that it should update the manifest and trigger the ArgoCD build. So let's see if it is happening, and it will test our GitOps as well. So it says the workflow is GitOps. What do we mean by GitOps? GitOps is a concept which is not just about getting continuous delivery and deployment on a Kubernetes cluster using tools such as ArgoCD. It's not just that. it is treating your GitHub as the single source of truth, right? That means now that we are making changes from the GitHub itself, whatever changes we have made from here, only based on that, it would have triggered the build. If I want to make the changes directly in the app from the cluster itself, it won't let me do it, because for that, this is the single source of truth and it will always be treated as single source of truth. So that is what we mean by GitOps. So let's see. I guess it's pushing the image. It's been pushed, but why does it show running? Okay, it is updating the manifest. This is what we need to check if it is doing those changes or not. So this file over here, this build number should be changed now. I guess it should be build number 5. Okay, let's see. Okay, now updating. Okay, now it throws the error that permission to queue manifest is it denied. Okay, so the image, see, it is now doing build 6. That's what it was trying to do, and somehow it didn't have permission to update this file. Let's see why don't, because this is a public repository. Oh, I guess this is because of our personal access token. Remember I said we'll see, like, whenever if we need to change any permissions, we'll figure it out later. I guess it does not have those required permission to make the changes. Okay, so let's fix our GitHub token first. Okay, it should be over here, settings, and deploy developer setting, personal access tokens, this one. This token does not have access to any repository. Add it. All repository. Okay, let's do selected repository. Oh, because I did not edit permissions. Okay, wait. To manifest. Now let's select the permission. Okay, so it should have the permission to read and write actions, I guess. It should be able to push the changes. That means give it this content access as well. I guess this should be good for now. What is that? No, we don't need it. Let's update. And now let's make the change again. Or let's just rerun this. Okay, this one. Oh, rerun from start. Okay, build and push completed. Let's see the update manifest. This is where it was failing earlier. Okay, cat, and build number should be 8. Yes, it was successful this time. So we were able to fix it. It was due to the access issues on our personal access token. And now it should push this new build to the Docker Hub repository, which is build 8. Let's quickly see. Okay, so build 468 is also here. And if we see this should also be running now in sync. Should auto start. Status is showing as degraded because it failed for a lot of time. Maybe that's why it didn't start the sync yet, because it takes few seconds for it to detect that changes has been happened. So let's wait. Let me do a refresh. Okay, so it has already started it. Let's see where it is right now. Okay, it has deleted the earlier pod and all is green now. So we have successfully completed it. Let's see if our changes are visible now. So we exposed it with a load balancer, right? So our app should be accessible on the load balancer URL. which is this one. Copy it. You can copy it from EKS as well. But here it is. Let's see. And here it is. 10 weeks of CloudOps. This is the latest change that we did. And to do. So to do for me would be week 5 challenge video. And yes, it will be done soon. So thank you very much for following along. That's it. I'll do the cleanup now. Thank you so much for watching the video till now. I hope this video was somewhat helpful in understanding and you were able to implement the project by following along the video. And all the links are in the description section, so you can, take the reference from there if you found value in the video. So make sure you give it a thumbs up, share it with your friends and colleagues who could take advantage of this learning opportunity. And don't forget to hit the subscribe button if you are new here. And I will see you soon with the next video. Thank you so much for watching. Keep learning.